exhaust gas recirculation system, the EGR system. The EGR is probably second only to the catalytic converter in its ability to generate hatred among car enthusiasts. The EGR valve literally takes some of the exhaust gas and forces it into the intake system. This takes up space in the combustion chamber, which reduces the heat being generated, but it also reduces the power being generated. So it literally is designed to reduce the output of the engine in order to reduce NOx gases, NOx, so our different combinations of nitrogen and oxygen. Like I said, over the years, it had a really bad reputation. Early systems back in the 70s, it was very common to delete them. Still, you see EGR delete kits available for diesel vehicles. We've seen as EGR valves have faded away on gasoline engines, they become more common on diesel engines. So we don't deal with them a whole lot on cars anymore, but if you're working on trucks, you're more likely to see them. The purpose of the EGR system, as I mentioned, is to control NOx gases, NOx. You'll hear some people say that is designed to burn leftover gasoline in the exhaust stream. It does do that, but that's just really a very minor benefit of the EGR system. When you see videos online where they're talking about it, the EGR system burning the excess gas in the exhaust system, just take that as a sign that the person really doesn't know what they're talking about. The main purpose of the EGR system is to reduce NOx gases. Modern vehicles, the engine controls and the designs of the engines have gotten very good to the point where the NOx, the EGR is not necessary for controlling the NOx. Between the design of the engine and the efficiency of the catalytic converter, the EGR system is not necessary on a lot of vehicles these days. So we see fewer and fewer vehicles with the EGR system. When you come across a vehicle that does have an EGR system, its purpose is to reduce the NOx emissions. Now, NOx gases are formed when the combustion chamber gets really hot. We're typically looking at around 2,800 degrees Fahrenheit, so really, really hot. At this temperature, the nitrogen, which is in the air, it just exists in the atmosphere. And when we pull in the air for the air-fuel charge, the nitrogen comes in. Usually it goes through the combustion process, cruises out through the exhaust system, through the catalytic converter, back into the atmosphere. When the combustion chamber gets super hot, 2,800 degrees Fahrenheit, that nitrogen will actually react with the oxygen and they'll combine, and we will get different combinations of nitrogen and oxygen. We call these our oxides of nitrogen. So there's a few different oxides of nitrogen. If you're interested, you can look in the textbook. It'll tell you what they are. But there are a couple of them, and we just refer to them as a group and call them NOx, NOx. The purpose of the EGR system is control that peak combustion chamber temperature by introducing some exhaust gases. All right, initially it doesn't seem to make sense. We're going to put hot exhaust gas into the intake, but it's still, those gases are hot, but they're nowhere near 2,800 degrees Fahrenheit. What those exhaust gases do is they take up space in the combustion chamber. When they take up space, that means we can get less fresh air and fuel in, and we're going to generate less heat. We see an illustration, a very crude illustration of an EGR system. On the orange side, we have our exhaust, and we see the exhaust gases coming out of the engine past the exhaust valve into the exhaust system. We can see our catalytic converter and our oxygen sensors. The component number 5 is our EGR valve. The EGR valve is going to control how much of those exhaust gases get into the intake manifold. So it's going to reroute the gases from the exhaust system into the intake manifold. Now, these gases have already been burned. Vast majority of these gases are inert gases. They're not going to burn again. So when they get into the combustion chamber, they get into the cylinder, they just take up space. So that's taking up space that normally would have been filled with fresh air and gasoline. So we end up with less fresh air, less gasoline in our cylinders. Therefore, when we have the ignition process, we're going to generate less heat. So we're going to keep the peak temperatures down below 2800 degrees Fahrenheit. NOx gases will not be formed. So this is going to prevent NOx gases. Unfortunately, it also generates less power. We have less air, less fuel, we're going to get less power. So that's the trade-off here. So as these exhaust gases are taking up space, they're keeping the temperature down. They're also causing the engine to generate less power. So it's important that we control when the exhaust gases get in there. We don't want those exhaust gases in there when we need the power. Key points at idle. We don't want these exhaust gases getting in at idle because they're going to cause the engine to run poorly. It'll stumble, might stall, we won't be able to get it started, might cause hard starting problems. We also obviously don't want these exhaust gases going in under full acceleration when we need all the power of the engine. If you put your foot to the floor and you're trying to enter onto a highway, you don't want to have a lack of power for emissions issues. You want to have all that power available so that you can safely accelerate. So we're going to control when EGR operates. Generally speaking, when the engine is idling, the EGR valve is going to be closed, and there's going to be no exhaust gas recirculation into the intake manifold. The EGR valve is then going to stay closed until the engine is warm and it's operating under load. We're not going to open the EGR valve if the engine is cold. Once the engine gets up to operating temperature or close to operating temperature, now the computer will start determining when to open and close the EGR valve. When we accelerate and we're under load, at that point in time, we can add the EGR gases, exhaust gases, in and start generating preventing the generation of NOx. Think about it, under load, that's when we're going to generate heat. That's when we're more likely to get those NOx gases formed. So that's when it needs to be controlled. Now, as I said before, when we get into heavy acceleration, then the computer is going to block off that EGR because we don't want to have a reduction in power. But under normal acceleration, normal load, the EGR valve is going to be controlling the gases going in, letting a little bit of exhaust gas in, letting more exhaust gas in, depending upon the application. On all of our modern vehicles, the PCM is going to control the operation of the EGR valve. Our really early systems back in the 70s, they were strictly controlled by engine vacuum, and they were really, really shoddy. So they earned their reputation for being garbage. And it made sense for a lot of people to pull the EGR valve off as far as engine performance. Obviously that damaged or impacted the emissions, but these things just operated so poorly that the vehicles at times were almost undrivable. So deleting the EGR valve from that standpoint made sense. As we got into the 80s and into the 90s, the computer was controlling the EGR valve. Early computer EGR valves were still vacuum operated, but the computers controlled the vacuum going into it. In the 90s, we started to see electric motors being used to open and close the EGR valve. So we get better control, more precise control that way. And that's when you come across a modern EGR valve, it's going to be electronic motor and it's going to be controlled by the PCM. Typical problems we have with EGR systems: carbon. Carbon, carbon, carbon. We get carbon buildup inside the EGR valves. We get carbon buildup inside the passages for the EGR valve. Remember, we got to connect that exhaust to the intake, so there are going to be passages. Sometimes it's external tubes that are going to hook up between the intake and the exhaust. Sometimes they're internal passages in the manifolds. They're going to get carboned up. There's nothing you can do about it. And it happens to every manufacturer, all vehicles, the EGR valves, over time, the valves will get plugged up and the passages will get plugged up. So they got to be cleaned. What happens is, as the normal operation of the system goes, the gases are going to be flowing and then they're going to be stopped. They're going to be flowing and they're going to be stopped by the opening and closing of the EGR valve. This is going to cause changes in temperature. So the EGR passages are going to get really hot, then they're going to cool off. The carbon that's in the exhaust gases, this heating and cooling will cause them to solidify. When they solidify, we get that carbon buildup inside, and sometimes it can be a soft, oily carbon, and sometimes it can be a real hard, chunky carbon like we see in the illustration. Now, this carbon buildup will typically do one of two things. It'll either block up the passages so that we can't flow exhaust gases into the intake, so we're going to reduce the efficiency of the EGR, or it can block the pintle in the EGR valve from closing so that we're going to be constantly flowing exhaust gases into the intake. So we can have one or the other. We can have too much exhaust gas going into the intake at the wrong time, or we can have not enough exhaust gases going in to sufficiently cool the combustion chamber. Either way, that carbon has got to be removed. Now keep in mind, when we reduce the flow of gases into the intake, this is going to cause the combustion chambers temperatures to rise. We're going to generate those NOx gases. That rise in temperature can also lead to detonation. So we get the pinging, the engine knock going on in the engine because we're not getting enough exhaust gases in to cool the combustion chamber. So we get that detonation going on. So a real common thing is, if we've got engine knock, if we've got engine detonation, that knocking means that we're generating NOx gas. So you'll hear people say NOx means NOx. So we're talking about engine detonation, knocking, pinging is when we're going to be generating our most NOx gases. Diagnosing the EGR system, typically you're going to have two common symptoms that the customer will complain of. They'll either complain that they have a rough idle, stalling, maybe hard starting, or they're going to complain that they have a check engine light on. All of our OBD2 systems are going to monitor the EGR. All right, this is a continuous monitor. It's part of the normal operation, the self-testing of the OBD2 system. The system will watch a variety of sensors, which is going to include our oxygen sensors, if we have a MAP sensor, our mass airflow, our coolant temperature. Some vehicles, Ford was big on this, had a sensor that actually measured the position of the EGR valve, so it would know if the EGR valve was open or closed, and it could actually measure the position. So you'll see a combination of sensors being used, and the computer will be able to determine essentially how much exhaust gas is flowing at any given time. If there's insufficient flow, the computer can detect that, and it's going to turn on a check engine light. If we have carbon built up on the EGR valve and it's preventing the EGR valve from fully closing, we're going to have exhaust gases flowing into the intake manifold at idle, low RPMs, and this is going to cause a stumble. This is going to cause rough idle, might cause a no start or a hard start condition. Typically, once we get off of acceleration and we're actually driving the vehicle, we don't see any drivability issues. So it's going to be lower RPM, idle issues, maybe a tip in on acceleration issue. But once we get above that acceleration and we're driving normally, we typically don't see problems with the operation of the engine. It's similar to what you would see if you had a vacuum leak in your intake system. On the other end of the scale, if we have a valve that won't open, or we have restricted passages in the EGR valve. We're going to have not enough exhaust gases going in, cooling the temperature, so we're going to have an increase in NOx. But this won't cause drivability issues under most conditions. Actually, the car might drive a little bit better as far as performance because we're not reducing the output of the engine with the exhaust gases. So the customer isn't typically going to come in and say, hey, you know what? I think my EGR is not flowing enough exhaust gases, because it's not going to be obvious in the operation of the engine. What's going to happen is the computer is going to pick up on it. So we're not flowing enough exhaust gases into the intake. We're not cooling down the combustion chamber sufficiently. When that happens, we start to generate NOx gases. The computer is designed to pick up on this and set a code, turn on the check engine light, and say, hey, we got a problem. So the customer will come in and say, I've got a check engine light. And then you as a technician will pull codes and you'll see, hey, we got EGR inefficiency. We don't have enough flow going here. So that restricted EGR isn't necessarily going to cause drivability issues, but it will turn on a check engine light. Don't ignore the check engine light, because when we have those NOx gases being developed, that means we also have the potential for engine knock, engine pinging. That can cause damage to the engine, so we want to make sure that we're addressing this issue, not only for the emissions aspect of it to keep the atmosphere clean, but also for the life of the engine. When we have restricted flow of the EGR system, typically what we're going to do is we're going to replace the EGR valve itself. You'll see people talk about cleaning the EGR valve. Personally, I've never had a lot of luck with that. And if it's for a customer's car, I'm not going to take the chance. I'm just going to replace the EGR valve. I'm not going to take the chance of cleaning it and not having it totally clean so the problem is still there. Just replace the EGR valve if it's needed. Even for my own vehicles at this point in time, I'm not going to waste my time cleaning the EGR valve. I'm just going to put a new one on there. Now, if circumstances were different and I really had to be concerned with the cost of it, then it might be worthwhile on my own vehicle to clean the EGR valve and see if it works. If it works, great. If not, okay, I got to bite the bullet and I got to replace the EGR valve. But again, for a customer, I'm not going to take that a chance. Just replace the EGR valve if it's needed. But keep in mind, replacing the EGR valve may not cure that problem. The restriction may be in the EGR valve, but it also might be in those passages. Typically, if your EGR valve is plugged up, your passages are going to be plugged up as well. So just replacing the EGR valve might not cure the problem. I've got a video here. It's a backyard video that some guy put together. And, you know, it's not a great video, but it gives really good illustration of what happens when the passages get plugged. Now, in this pilot, getting access to the passages is really very easy. So cleaning them is pretty easy. Most other vehicles, it's going to be more difficult. You're going to have to snake in with a piece of wire. You're going to have to go in and use cleaners, all different kinds of things. But this one shows pretty good illustration of what's going on. So click on the video. All right. Make sure that you work on the worksheet and answer the questions on the worksheet using this video. And be well.